Thank you, Lavinia, for the presentation, and good afternoon, everyone. I am Alessandra-Corneli. I'm a researcher from Università POLITECNICA delle Marche in Italy. So, unfortunately, we are all aware that the fact that the construction industry is the industrial sector with the highest number of fatal injuries and fatal accidents. And we can see that this is true from both the side of European statistics, as can be seen on the right, and USA statistics, so it's a worldwide problem. According to OSHA, these are the called fatal 4 construction issues during the construction processes, so falls struck by object, electrocution, and cocked in or in between an object. So these are the causes of most of the fatal injuries. But we can also see in the graphic on the left side of the slide things like inappropriate vehicle startup, contact with vehicles, loss of control with vehicles. So the thing that is understandable from this statistic is the fact that procedures are the most complicated things to follow in the construction industry, and we will see the reason why. And this lead to the most highest percentage of fatal injuries. The reason why the construction site is this well-known cause of fatal injuries is the fact that it is a complex environment. And the complexity is done by the fact that it is on conformation, so the fact that it's changes during time, and it changes also location, so we are not in an industrial factory, common industrial factory, and so the nature of the environment carries the highest risk. Not only this, but as we have seen in the statistics, also the fact that the proper execution of procedures is a critical aspect, because we don't have a procedure well traced inside the industry, so they are difficult to follow and to follow in a rigid way. The thing that we wanted with this work to introduce in the construction safety is the stigmergic approach. I will say this strange word, and this came from the animal side of the word, because stigmergy is the process with animals that animals use to leave traces in the environment that other animals that for us in the construction site will be agents, can detect and follow in a natural way, so as that they follow the right path, the right process in this case. And this is in our work and in our approach goes together with the safety to approach, because the safety to approach is that a newer approach to safety that foresee the use of the fact that you don't have to give prescription to follow, so say things that don't have to be done in a certain way, but on the other side, you should push operators in all the construction, in all the safety problems to follow the right way. In this perspective, the digital twin approach seemed the natural approach, the natural paradigm to put in place, and we in this application we decided to work with two technological aspects. From one side, the agent localization. This is a quite known technology. We use UVB or Bluetooth for inside construction sites, but also we develop some application with GPS and RTK tag for the outside. And this is the information flow that I think we all know in the digital twin construction from the physical space to the virtual one. But there is no digital twin, the proper digital twin, the complete digital twin, I don't know what you would like to call it, if you don't have the way back of the information. And we decided, so as to follow the safety to approach, the stigmergy and the things that I already explained, to use the NLP, so artificial intelligence, to give messages back to the site. The architecture is this one that you can see in the slide. So we have, of course, the physical layer. In the physical layer, there are the sensors that I already explained that gives data to a digital twin platform. This digital twin platform came from, it's a further development of a platform that we developed in my research group with a previous research. The previous research was quite static, then we added the dynamic part for the digital twin development, and we used the digital twin platform because this was the environment where we can define the rules, define the spaces, and for defining the spaces we decided to use BIM IFC, and define all the agents that are involved in safety. Furthermore, also in the digital twin platform, we call actually the service of natural language process. And then you can see in the architecture the information flow way back with the speech, with the text-to-speech to the operator through equipment like this, like the helmet. The platform, as I said before, was used for all that development, so the rules and the agents, but most of all for defining the spaces. The platform works with an IFC engine that transforms IFC in a graph database, in a graph representation. And as you can see, this is a construction site where we are starting to install system like this. The tests you will see have been done in our laboratory. So as you can see, for instance, the spaces, and then we will see why we need the spaces, are defined directly in BIM, which is a tool that every kind of operator of the sector can be used, during design phase and during the safety design phase. These are the application that we develop for NLP for safety. In this application, we defined all the agents. You can find them on the left side of the app. So there were equipments, the operators, the training certificates, and all the things that we need to then monitor the situation. On the right side of the screen, of the screenshot of the application, you see how we define rule. So in this case, it was a distance threshold above the one some alarm starts. And these are the rules that we define, the way we define rules. And here we also define, of course, the vocal message that we give back to the site according to some situation. These were the tests that we have done in our laboratory. We've done 3 tests. The first one was the identification of interference risk situation. In this case, we were inside, so we didn't use the GPS RTK tag, but we use a UVB system. Also because in our laboratory, we already have that installed as an infrastructure. So we have the tag on the carrying load and also the tag on the jacket of the operator. In this case, the condition was distance below 50 centimeters, and in that case, the operator has a headphones that you can see in the next slide. The message is Alessandro, in this case the name of the operator, you are about to make contact with the overhead crane. So in this case it was just a spatial conflict. Also the spatial engine is inside the digital twin platform. The second test that we have done is the verification of possession of the qualification. So in this case, of course, the operator agent is modeled in the digital twin platform, and then there we put the qualification that he or she has. And here, also in this case for distance, with the minimum distance set to 20 centimeters. When you are below 20 centimeters, the system is able to querying the platform where all the information are inserted and ask, in the case it doesn't find the right certificate to move the crane, Alessandro, you are or are not in possession of a license to drive the overhead crane. Of course, on the left side, you see the actual situation inside the laboratory, and on the right, where the tag were localized in the space that is actually our laboratory space that we modeled. The final test, it was the verification of possession of permits to access the area. In this case, the operator is always localized through the jacket, because the jacket has the UVB inside. And in this case, also the cones has the UVB inside. So they define the real space that has to match, of course, to the space previously modeled in BIM. And in this case, the verification can be done. So it can be detected the person inside the real space and then verified that the person has the permits to be in the real space, or they are not doing a dangerous operation. So in this case, the message was, Alessandro, you do not have permission to access this area. To conclude, one of the conclusions that we ended, also because we started work at that construction site that you see the model at the beginning. It is well known that recent technologies and latest technologies still struggle to enter the construction site, and more than all, the safety procedures, and also that changing processing and also standardizing them is seen as a difficult. The next step that we would like to pursue are the integration of this technology and application in a whole safety helmet. We will also try to test some noise reduction helmets. And then, of course, since we have that construction site, testing with operators on site. Thank you.